Hey guys, Rich here. Not sure exactly where I'm going with this video. It's more of an audio to me. I'm actually not looking at anything. I'm just talking into a microphone. Maybe this is just going to be a little bit of a philosophical flat earth type of video. One thing I need to talk about is the triangle video, the last one. I made a big mistake on that. Two of the angles on the earth were actually correct, 60 degrees. And I mistakenly took the third angle and just wrote 60 degrees like I would if it was in plane geometry. And that's absolutely wrong. The top angle is much larger than 60 degrees, which is of absolutely no consequence. The bottom line there is that the two angles, once you have a base, which I started with, the equator, and then you make 60-degree angles off of that, of which I am absolutely convinced they are good 60-degree angles because I made a 60-degree angle on paper and cut it out. And I used that angle to start my lines. And once I started the lines, all I had to do was extend it. The bottom line there is that if you make two 60-degree angles off of that, that you will end up with shorter legs on the sides than you did with the base. And that is a difference in time that we're going to be able to measure with the sun, or maybe not. Maybe there is no difference. But there is something even more fascinating with that. Dave did the same experiment, and he made a triangle with equal sides and equal angles, 360-degree angles. He cut it out, laid it down on the earth, and traced it out. And it took him quite a while, but he found 3 different cities. And I believe that there's a discussion on this on the Mr. Thrive and Survive Facebook channel. In any case, he laid this triangle out on the globe, finally found 3 different cities. What was interesting was he found one that worked. It takes a long time to match up 3 cities. I matched up 2. That's how I was able to give you how many miles it was. From one location to the next. I matched up Seattle, Washington, and Pearl Harbor, of all places. One of his cities was Eureka. I'm not sure what country it was in, but Eureka was one of the cities, so maybe a little message there. In any case, what he found out was he marked the 3 cities, and he had a huge triangle. And he then went to Google Earth, opened it up, and you've seen me do it too. You've seen me put rulers down on Google Earth and measure from one point to the next. And the interesting point is as large as his triangle was, you know, with what they tell you, there's supposed to be so much overflow or whatever, so you can't do this on a globe. Well, guess what? All the cities, all 3, were within 50 miles of one another. Now, granted, he just picked the middle part of each city where it was and did it on Google Earth, but there should have been thousands of miles error with taking a flat triangle like that and laying it out on Google Earth, because the shape of the earth should have made a difference. So what does this tell us? This tells us that all the miles on Google Earth from point A to point B, wherever you have point A to point B on Google Earth, it represents the distance on a flat plane, not the distance on a sphere. So isn't that something? So the question is, can we really find a triangle somewhere that says if we have a sphere and we make a base of so many miles long, mine was about 8,500 miles long, and we take 2 60-degree turns off of that, which are really 120 degrees relative, which forms 2 60 degrees at the 2 legs moving off of the base. What is the distance of the 2 side legs? That is what we mean by I can't find a calculator that works. Can anybody do that? Now, it should tell you on a sphere, if you've got the 2 angles, 60 degrees and the distance of the base, it should tell you the third angle and where those 2 points should meet. That's what I haven't seen. I'm hoping that somewhere that exists. Otherwise, I guess we're just going to have to come up with the math ourselves. We're going to have to keep doing this and measuring it on different size spheres and come up with the formula ourselves. Now, it doesn't matter what size the sphere is. It should be the same no matter what size. but it's easier the larger we get. The larger sphere we get, the easier this is going to be to figure out the exact distances that this would produce. And I'm going to say this one more time again also. We don't need 60-degree angles. We can make a base, make a 90-degree angle, and then we can compute the other side, what that angle would be, or the other two angles, and the hypotenuse on a sphere. Where's the calculator to calculate that? Because you can definitely make a 90-degree turn, can't you? So we showed that. So when people say, no, it's impossible to make a 60-degree turn on a globe, well, I just don't get that. It just doesn't make sense. Or a 90-degree or whatever degree. You can do anything you want. Now, you know, one of the supposed utterly dumbed down, stupid proofs that you live on a globe. And, you know, it's so stupid I didn't even pick this up when I went to debunk it. But what it says if you start at any point, and if you start at one area, maybe even say the North Pole, I can't remember, but they do start at the northern part of their little ball they're holding, and you travel 10,000 kilometers south, and you turn 90 degrees, and you continue another 10,000 kilometers. And these are, by the way, these are proofs you can do yourself to prove you live on a spinning ball. Well, I'm sorry, proofs that you live on a ball. Maybe they do say spinning ball. I'm not sure if they're that stupid, but anyway. And then, of course, you make one last 90-degree turn, and you end up right back where you started. Well, that is not proof you live on a ball. That is just proof that you measured a ball. Now, who the heck is going to walk 10,000 kilometers, turn 90 degrees, go another 10,000 kilometers? And by the way, 10,000 kilometers, they're taking you pretty much from the pole to the equator, and then 10,000 kilometers over, and then back up to the pole again. Utter stupidity. Utter stupidity. Which nobody can prove. And these are things you can do yourself. So I'll tell you what, I'll give $10 million. Actually, you know what? We could all actually back this up. We could all pitch in whatever we can pitch in. We can get enough people to back up $1 million prize for the first person that walks 10,000 kilometers, turns 90 degrees, walks 10,000 more kilometers, turns another 90 degrees, walks 10,000 more kilometers, and ends up where they started. You see, that's impossible. You can't walk 10,000 kilometers anywhere on the earth. You just can't do it. Unless you're Jesus and walk on the water, then you can do it. 10,000 kilometers. You're going to walk from the pole to the equator, then the same distance from the pole to the equator, let's say due west, along the equator, and then you're going to turn 90 degrees and go back up to the pole again. So you can travel 30,000 kilometers on foot. Yeah. You can own my house if you do that. Show me that you did it. Okay? I'll just give you all my possessions. All of it. And it just goes to show the low-life stupidity that they throw at us. And people call us stupid for wanting to believe what we believe. And you know what really got me in the last week was somebody put together a compilation. I'm sure it's probably been there for a while. Maybe I'll find it and put it up here. Here it is. Who forgot to spin the earth? Let me go back to the beginning so you can take a look at this one. Let's play it and take a look at a few little things here that just boggle the mind. Why one person would see this live once. Just once. But I want you to notice here, who forgot to spin the earth? Look how fast the animation is with this, and the earth is just barely trucking along. Compare that to what you see next with movements of other things in the foreground on the space station and how fast the earth is moving. Just a slight inconsistency. Look at that. Look at that spin compared to the bottom. Here we have the guy who goes around, when he goes down to the corner, he disappears. Remember that? Sure, you remember that, don't you? Let's see if we can catch it right where it is. There you go. You start to see through the guy. Evidence of green screen. We don't have to see the big blue screen in front, do we? Nah, we don't have to see it. Isn't this where it was hanging? When we saw it in the picture supposedly in the back? When it wasn't up front? Yeah, we remember this. One time, that's all it would take for me. One time. Why would they lie one time to us? Oh, he disappeared. Did you see him? He's just a spirit in space. And, you know, I apologize if you guys have seen this. He's going to hit this little strap down here, and it's going to accelerate. Let's take a look at it. I'll have a link to this video at the bottom. There you go. Yeah, that certainly happens up there. This is the one that got me. This really got me. Look at this guy's arm. Okay. Oh, turn mechanical for a second as it jumped down. Now the microphone actually changes. It actually turns into a different microphone at the bottom. Watch. Bleep. Oh, no, that's real. Yeah. Oh, yeah, baby, that's real. Coming up with some realism there, baby. NASA. You know, I didn't notice, watch the watch. I didn't notice what happened with this one. Maybe you guys can tell me. It's a patch. Oh, yeah, it is. Absolutely. There's a patch there. Unbelievable. Look at that fake perm she's got. Why don't they have a guy go up there with long hair? Oh, this is where the guy's finger goes out of joint 2 or 3 times. Oh, her finger. Watch her finger there. Pop. Look at that. Not only out of joint, but out of place. Yeah, these are absolutely real. Ask yourself the question if you believe it's a globe and you believe NASA has a space station up there. Why one time would there be an error? Here we go. Here we go. Watch, this is what I was trying to show before. All of them at once get thrown to the left in the International Space Station. I'm going to pause that. I'm going to go back to that one. You know why? So many people gave me grief over that one picture or that one video I did where you had Mr. Uppity Up jump up and down. The guy that went up in space for over a year and got fat. He actually gained weight up there while he's trying to grow his own vegetables and having problems and eating powdered foods and supposedly losing muscle weight as he's up there. And no matter how much exercise you do, this guy comes back 15, 20 pounds heavier in a year. Yeah, And these guys in the International Space Station are thrown against the bulkhead. This is because the plane was coming out of its dip or its great climb so that they could simulate the no gravity. Freaking fools want to believe this. Here, this gets me too. People, you know, I told people this. I told people about this, about the bubbles in space. You didn't provide a link, you're just saying this. Well, guess what? I provided the link, they wouldn't look, never came back and said a word. Cowards. But that's all right, they can be cowards. There's a lot of cowards. Here we go. In case you didn't notice this right here, look at this. This is a guy, again, I'm sorry guys, most of you probably have seen this. Here's a guy in an obvious scuba gear with a camera taking a picture of this guy in space when he's really in a black pool here on Earth. Crazy stuff. Scuba diving suit is right. You can make it out. Crazy, crazy. You want to believe it though. Look at that bubble going up. Should you ever see one bubble in space? Absolutely not. There wouldn't even be any pressure to form a bubble. So if you want to say, oh, maybe it leaked out of inside the spaceship. Yeah, well, everything would have leaked out and there's nothing that even cause a bubble. Nothing. Zero pressure. Instant vaporization. There's the Earth as it should turn, I guess. This is what they keep showing us. Uh-oh. The Earth didn't spin too much there. That's right. Someone forgot to spin the Earth. Somebody forgot to use their freaking brains when they believed this stuff after this. I really wanted to believe this, guys. I was a big Star Trek fan. I really was. I was a big Star Trek fan. And I was a little kid, and I stayed up 2, 3 in the morning watching these Apollo launches and the different things they were doing to see if they did it right in the middle of the night, if they were successful. Yeah, I wanted to believe it. So here's the bottom line new revelation, guys. Make yourself an equilateral triangle, 360 degrees. Do it on paper. Do it something flat. 3 60-degree turns, equilateral, same lengths each side, A, B, and C. Lay it down on Google Earth, and of course you'll be able to bend it at the ends, won't you, because it's a sphere. Mark the distance between cities. Go to Google Earth and measure it out, and guess what? They're all going to be equal. You know why? Because the Earth is flat. And if they didn't give you the measurements on a flat Earth, people would realize, wait a minute, I know it's a lot closer from this point to this point. This doesn't make sense, Google Earth. Try it. Go ahead and try it. You're going to find out that the impossible, everybody bought into it, didn't they? It's impossible to have 360 degrees equilateral triangle on a sphere. Lay it out, tape down the edges if you want, measure it on Google Earth, see what the distances are. Be very accurate, and you'll find out they're within 50 miles, which they should be much different if it's a sphere. The Earth is flat, guys. Have a good night.